name's Rip Martin, and this is a supplement to my video on unified theory. I wanted to go a little bit farther and make a tape describing the fundamental forces and how the Kepler effect and time waves, which I presented in my last argument, do account for all of the known forces. I'm going to go through a quick refresh of the subject matter in my unified theory video, but explain how each one of the forces can be tied to space-time, and how the Kepler effect facilitates some of our observations. So the Kepler effect is actually the fact that the equal-area law that Kepler came up with is not right. The acceleration and deacceleration of the orbiting body in an elliptical orbit causes motion in the orbited body. So in the case, I did a study of Pluto, but the most important part is that the mass of Pluto, and I'm using Pluto as an example, the mass of Pluto, the acceleration of Pluto has to equal the mass of the Sun and the acceleration of the Sun. So as the elliptical orbit speeds and slows down the orbiting body, that work being done by the orbited body is showing up as acceleration in the orbited body. And that acceleration is work being done, and that is the mechanism that gives you the ability to transfer motion through space. Now, when we talk about atomic scales, now we introduce a relativistic speed of the particles involved in an atom. Then the Kepler effect, or that acceleration due to the electron, is a mechanism to transfer heat, a mechanism to transfer motion. Sorry. So it's the mechanism that you can get movement across the vastness of space. So we have an elliptical orbit that is exerting a force on the orbited body. So some of the planets could have been captured, some of the planets could have been accreted, but this mechanism, which gives you acceleration in the whole system if you induce an elliptical orbit in the orbiting body, is the mechanism that allows transfer from a great distance movement into a local system. Now we tie that to the time wave scenario, and a time wave has a very high effect on something moving at a relativistic speed. So it's important to understand that a time wave only affects things moving at time speed. That once you get down to a near timeless state, then a time wave has a severe effect on you. We talked about magnetism, and how magnetism is actually a standing time wave on a magnet. So the magnetic lines that are on a diagram of a magnet are actually standing time waves. those standing time waves affect anything moving in a timeless state or relativistic speeds. So if you take a coil with individual a conductor with individual atoms, then as a magnet goes through the coil, the time waves associated with the magnet cause an elliptical orbit in the orbiting body of the conductor, which that produces electricity. Electricity is not electrons moving down a wire. Electricity is elliptical orbits being transferred at the speed of time, atom to atom in the conductor. And that motion is the general fundamental motion that allows you to transfer movement from the sun to your skin on a sunny day. That's how you manage to get movement in the atoms and the cells of your body, is by time waves inducing elliptical orbits in the atoms, and that causes movement in the whole atom, which is heat, movement. So time waves explains your ability to transfer movement across interstellar space. It also describes the phenomenon of magnetism. It's a time wave that influences conductors, and those time waves have an effect on anything moving at time speed or relativistic speeds. So that gets us electricity, which is elliptical orbits in the conductor moving down the conductor at the speed of time. It gives us magnetism. Magnetism is a derivative of time waves, which time waves give you electrical force, but the electrical force is a combination of time waves bumping up against each other in elliptical orbits. So it's a combination of elliptical orbits and time waves that allow you to have electricity, and this mechanism is what magnetism and electricity is. Now, if we go to an atom and we consider that we have a electron moving at the speed of time, making time waves. So this thing's making wakes in time, and those wakes tend to push things away. The proton is spinning at the speed of time, and spinning at the speed of time tends to make a vortex. So the vortex is actually drawing time into it. So that's the reason that a proton is a positive charge, it's drawing time in. An electron is a negative charge because it's pushing time away. This is the charge of a proton and an electron. It is a function of time. It's a function of time moving forward or backwards or being compressed or expanded. This is what the charge on an atomic basis it comes from. Now, it's a little confusing, but I want to introduce right now that I think that electron has a energy level related to achieving the speed of time. I think when it hits the speed of time, it releases energy. So if a time wave hits an atom and technically knocks the electron out of time speed, it probably does it either momentarily or it does it in a way that it can change orbitals. Well, that change in speed for a split second releases a time wave, which is a photon. So that photon is being released by the electron going in and out of time speed. So the electron is emitting a photon when it goes to light speed. Now would be is appropriate to also mention that we also have time waves in a vast number of wavelengths. Well, those wavelengths also have an effect on scale and size. A high frequency time wave that gets to a frequency that is closer to the size of an atom has a different effect on an atom than a broad, wide, low frequency time wave. That demonstrates part of the differences in the characteristics of infrared, visible light, microwaves. All of those are time waves, and they behave differently based on the frequency and how that frequency relates to the scale of the atom and its ability to change motion. So remembering that we think that we have a proton, which is positively charged because it's spinning at the speed of time, and a neutron, which is same particle spinning at sub light speed, time speed speeds, then gravity holds those two together. And it can only hold one additional neutron if it's hydrogen, or based on the flexibility of gravity, you can have additional neutrons in a nucleus in isotopes based on the range at which a slower moving neutron could attach itself to a time speed spinning proton. And this configuration, I think, is stable, and everything that's on the periodic chart is stable based on the wavelengths that the electrons are making, and the interference associated with additional electrons in those orbitals. So we're at electricity, we got magnetism, strong nuclear force is actually tied, I think, to the fact that your spacing is going to zero. So if gravity has a divisor of R, then if that R goes to zero, then that force gets infinitely larger. So the strong nuclear force is actually gravity, just gravity associated with a zero distance or near zero distance. The real beauty of what I'm offering is the fact that from the beginning you could have had matter and nothing. And if space-time is configured with the right constants, which we know it is because we're here, then you could have taken matter and added motion with the space-time constraints, and you would have what we have right now. You would have the universe. And all you would need is the right constants and motion. And I think that space-time is created when you separate matter. So I am offering a unified theory. All of the things that are associated with the standard model of different particles behaving differently, that is associated with size and the speed of time. All of the particles that we found, it just matter at different sizes, and they behave differently at different speeds, and are influenced by time waves differently depending on their relative mass to time speed, and all of the atomic forces are created by motion and time, and the flexible nature of time. Now, I've covered this before, but just reiterate that the reason Schrödinger's equation works as a probability is because the particles they're trying to measure are traveling in a timeless state. So assigning a time to them doesn't make any sense. And since the electron is traveling and making time waves, then if you assign a time to it, you knock it out of time speed, then the wave collapses, the wave that it's making because of its speed. So if you look at this equation, and the kinetic energy is the main one I'm looking at, the h bar introduction is a frequency Planck's constant number, which also leads you to believe that they have scaled this thing to an atomic size. So part of the wave function that they're trying to get out of this is based on the size of the atomic structure, and that the wave is really a time wave. And until you take this wave and actually designate exactly where it's at in your supposed box, then a probability is all you're going to get. I have some more thoughts on that, but now, if space-time is created when you separate matter, then isn't it possible that there is more than one item generating time? And what I mean by that is I'm leading towards a black hole. A black hole is matter without space and time. So if you take an atom, you take all the motion out of it, then gravity is going to pull the whole thing together, and you're going to have a speck of matter that weighs as much as the original atom. You put quadrillions of those particles together, and you eventually get a black hole. So it is matter without space and time. The confusion is tied to the same thing I talked about with strong magnetic force, is that when you divide by, when the denominator goes to zero, what does that mean? Well, I think that's where you get the infinitely dense theory of black hole. And I've seen this mistake being made a lot in physics, and I think the standard model is a demonstration of it. Those are all particles that have been sized based on the stress they go through, just like the sands on a beach. The reason an electron is as small as it is because of the stress of going to the speed of time, the speed of light. The stress that that puts on the particle causes it to split. And the size of a proton is based on the strength of the matter that can spin at the speed of time. Something spinning at the speed of time is still offering a tremendous centrifugal force. So the protons and neutrons and electrons are sized as if they're sands on a beach by the stresses that they have to go through. I think all matter's that way. All matter has just been pounded and crushed over the infinite amount of time that the universe has been in place, that it eventually has come to be sized based on the stresses that it has been exposed to. So that stress then manifests itself, or that those sizes manifest themselves in the motion of the particles, how heavily they're influenced by time waves, and how they interact with each other. So back to my black hole. So black hole is just matter without space and time. At some point, a black hole will get big enough and become unstable. And what I mean by that is the centrifugal force of that material spinning will eventually cause it to blow up and rupture. I do not think that we have seen one. And what I mean by that is I think the Big Bang was for our galaxy. And if you look at all the observations, it appears that we're in the center of an expanding universe. Well, what is the best reason for that? The best reason is that our galaxy is the center of the Big Bang. Then our existence is expanding into existing space-time, an existing universe. That's the reason that we observe everything going away from us. That would also mean that there's some anomalies because there is space-time that originated from somewhere else pushing against our space-time. But I think this just seems obvious to me. All this seems obvious to me now. But if you observe the universe the way it is now, rapid expansion is just bullcrap. It is much more likely that we have not seen a galaxy explode because the time frame that a galaxy works off of is so slow. You have maybe trillions of galaxies, but if their life cycle is trillions upon trillions of years, and that's a very good possibility. Looking at our galaxy, we're very active now, but we're going to have red dwarfs that can manage 1 trillion years. And the motion that we see, how long will it take for all of that material to return back to the black hole? When technically you have stable orbits of everything around the black hole. So these are very long life cycles, and that's the reason I don't think we have observed one of them. But if you think about our time moving off, then it makes perfect sense that the age of the Big Bang for us is about the edge of where we can see, the 13 billion years. It's not a coincidence that that is the limit of how far we can see. That's how far our existence has gone. And the fact that things are moving away from us proportionate to distance means that that expansion is expanding at the speed of light at the edges, and then the volume where we're at is expanding at 1/14 billionth a year. So that makes most of the observations that we see make much more sense. And the background radiation, well, it would still be there if it was just for us and it was expanding into an existing universe. None of that's contradictory. Matter of fact, I think my explanation makes much more sense with the observations. If you take this moving space-time and you plug it in, then each one of the galaxies that you observe, that you claim is dark matter, has a different coefficient of expansion. So that difference in coefficient of expansion would dictate that your gravitational attraction orbiting calculations would not be correct, because you have an expansion coefficient for each galaxy that is different. And it's based on how old that galaxy is. I really do think that the universe is infinitely old, that it has, all matter has been recycled through explosion, Big Bang, supernovas, and just a number of different effects. Now, but one of the things that's really important to realize and is very fundamental is that space-time, or time itself, if you have a time wave, that time wave really is outside of our reference of force equals mass times acceleration, because of the fact that conservation of energy works, tells me that time is transferring that motion in some clear mathematical formula. I would also think that your electrical volt reading for electrons is actually a definition of the time wave that the electron makes when it switches, either orbitals or jumps in and out of light speed. I think there's a lot of the research that's been done just needs to be reevaluated for what it really represents. Is it representing a time wave that's transferring motion? Is it a jump in momentum based on its circumference around the nucleus of the atom? There's a lot of questions to be answered there. There's strength of material questions. I've still never seen anyone try to define the density of matter, the actual density of straight matter. And then that gives us a strength of materials. If going to the speed of light causes a shear effect that dictates the electron size, then those forces could be figured out. Now, finally, we'll say one other thing, and that is the reason that I figured all this out is because I've been working on a light speed engine, and I'm still very close. I think I know how it's done. And that's the reason that I want to continue my research, but This is the way the universe works. I just don't have any holes in my argument, and my argument is that the world is extremely simple and extremely complicated at the same time. It's simple in its basic function in that we have matter, space, and time, and gravity. Gravity is the only force, and space-time makes up everything else with matter. So it's all motion. And there's no other weird particles, there's no other anything. It's all just motion and the effects that time have and the way time propagates through the universe. And particularly how the characteristics of time affect particles moving in a timeless state, and it's important to know that the ununderstandable part of quantum physics is ununderstandable for a reason, because it's wrong. There is no spooky motion at a distance. It's all because of time waves and the effect of shooting a time wave at an electron to measure it. The electron is making a time wave. This research needs to go forward, and this is the way the universe works.